Hello and welcome. Today I'll be giving you an introduction into the Numpy module in Python. Now, by the end of this, you should have an expert knowledge of how to use the Numpy module. Now, what the Numpy package or module is, it's pretty much a scientific calculus and sort of statistical package that can be used within Python software. It's also pretty much the go-to package that I use, and I know that most other people use for creating random numbers or random number generation, because you can create as many as you like in whatever range you like, and incredibly easy and very quickly. And it's also a very powerful tool when combined with graphing modules like matplotlib, and also use it with other modules like SciPy. So all in all, Numpy is a very great module or package to get to know and to understand. And that's exactly what this tutorial is about. So I'll be splitting this into 4 different sections. So the first section will be going over random number generation. The second section will be looking at creating matrices and then ordering matrices. And then the third section will be array calculus, which I'll be showing you other ways in which you can add, divide and subtract, and so on and so forth. And then in the last section, I'll be showing you how to do date time in the Numpy module. So if you've never come across Numpy before, you're a complete beginner, or if you just need some refreshing in how to use the Numpy module, then by the end of this, not only should you have a good knowledge, but you should be able to apply it well and be able to use it very comfortably. So let's get started. So the first thing you've got to do is zoom in so everyone can see. And this is our module here. So as you can see, I've written the codes before to make it quicker and easier so that this can run more smoothly. So the first thing I'm going to do is import Numpy as NP. So NP throughout the rest of this tutorial is how we're going to refer to the Numpy module. So let's go into the random module. So here, to get random whole numbers or integers, you type in np.random.randint. So np.random.randint, and then you specify the starting number and then the final number, and then the third section is how many you want. So let's say you wanted to simulate the rolling of a die. So a die has 6 sides, so the random numbers we're going to choose is between 1 and 6. So remember, Python starts at 1 and then you have to go to 7 because it doesn't include the final number. And then let's say you just wanted 1 die, and then this is exactly how you do it. So then if you just run it, here you've got number 1. If you look at the output to the right, you'll see that your number 1 has appeared. And then we can just do it again. They're all randomly generated. So let's say we wanted to simulate, let's say we roll 100 die, or 1 die 100 times, or 100 die once. We can then run it again, and we have all these numbers here appearing. So what is done very quickly is randomly choose a number between 1 and 7, or between 1 and 6, and then 100 times. So that simulates, either rolling 1 die 100 times or 100 die once. So that is a very great way of simulating dice roll, or you can also do the same with sort of coins if you wanted to. So you could print between number 1 and 3. If you had, say, heads as 1 and tails as 2, you could then run it, and then you'd have a whole list of 2s and 1s, and then you could put up here, I don't know, h equals 1 and t equals 2 for heads and tails. And so that's also a really great way of simulating roll dice, coin flips, etc. I've done simulating rolling die and coin flips in previous tutorials. So if you want to know more about that, then feel free to look through my YouTube channel, and then find the relevant tutorials. So these are whole numbers. So what if you wanted to, I don't know, calculate random probabilities, in which case you'll need non-integer numbers, or percentages, in which case you will need a number between 0 and 1. So if we go to the next example below, and then let's scroll down the output, get a nice blank area, and then we run this on again. As you can see here, we have now got we've got 10 numbers between 0 and 1. So if we want to print out, let's do another 1 number between 0 and 1. We have that. And how you do that is, you, instead of doing rand int like we did earlier, you type in random sample. So in our list of options, you see, if you scroll down, you have random sample, and then we just choose our sample size. So here we can choose whatever we want. So let's have 100. We get a list of 100 random samples. And if you wanted that expressed as a percentage, then all you have to do is times that by 100. So let's say we wanted randomly chosen 10 percentages. There we go. And that, so what we've covered now is we've done random sampling with integers and random sampling with float numbers. So let's go on to the next thing, which is a random choice. So let's say you had a list here, or you created a list using the random integer number or the random sample, and then you wanted to I don't know, have a random selection between 1 and 8. So again, another option in the random is .choice. And then all you do is you reference whatever list you have, and then you print it out. So we've got to randomly choose a number between 1 and 8. So let's run this a few times. As you can see here, it's randomly selected a number between 1 and 8, including 8. And so that is a really great way of randomly choosing values, or randomly calculating, I don't know, using probability or statistics, or even, you know, making something fair. And, you know, it's really great. And so the next thing we're going to do is we're going to move to a random shuffle. So in a previous tutorial, I have created a pack of cards, and then I've randomly shuffled them. And if you've forgotten how that's happened or how that works, then what you can do, and then let me show you, and then I will show you how this works. So first thing you've got to do is, like this, you've got to create a random list of 5 numbers. So here we've done is I've typed in np.arange. So I've selected a range of 5, so it's going to print out 1, 2, 3, 4, 5. So if we do that now, 0, 1, 2, 3, 4, sorry, yeah, because that is 5 numbers, but remember, Python starts at 0. Sorry about that. So at the moment, they're ordered pretty nicely. So what happens if we wanted to shuffle it? We type in np.random.shuffle, exactly the same way as choosing random int, random sample, and random choice. And then we reference random shuffle. And then if we print it again, notice that it's changed, and the order is changing all the time. So you see here, they have all changed. But if we take that back out again, notice that the order will go back to 1, 0, 1, 2, 3, 4. So let me do that again. So type in np.random.shuffle, and notice that the order is randomized. I like to point out that even randomly, you could still get 0, 1, 2, 3, 4. The chances are very small, but that could still happen. So I hope you've enjoyed that section on randomly choosing and shuffling and selecting whole numbers and non-whole numbers. The next thing we're going to do is we're going to look at creating matrices And then this is a great way of including statistics. And then also, if you're very into your maths and mathematics, you would have come across matrices expressed in a way of sorts. So first thing we're going to do is we're going to create a random range like we did. And then, so if I print x4 now, you'll see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I wanted to reshape, if I wanted to express that not on one line, but have, say, 3 lines of 3, you may notice that we had a problem. But that's because you have 10 values and we essentially only have space for 9. So that's one thing just to be aware of when you're trying to create matrices. So if we just quickly modify that to show 1 to 10, which will show 1 to 9, and then we rerun that, it's not working. Okay. So why isn't that working? You can't array size 10 into. So let's just do this then. 5, 2. There we go. So that is our array there. And then, or we could go 2, 5 the other way around. 10 doesn't break down too well, but if we had 12, yeah, there we go. So that's an example of creating a matrices. I don't know why it didn't work for the other one, but let's try this. Oh, there we go. Oh, brilliant. So, yeah, where I went wrong last time was I had 3 values here when you just want how many you want in the rows and how many columns you want. So that's just one thing to be aware of. I fell into that trap just now. So if you want to change the number of rows and columns we wanted, then we just do that. And boom, we have our matrix created between a range here. Notice that I've used a range rather than creating the list like I did up here, or creating random values up like I did up there. So there's many different ways of creating lists and ranges. Another one to be aware of is another very easy way is to use the I function. So here we typed in a range 1 to 13 and we reshaped it to whatever rows and columns, a specified number of rows and columns. Whereas here we have created our matrix 4 by 4, or if we wanted to 3 by 3, or we could have 10 by 10 if we really wanted to. If you notice here on my output, let's go back to 4, and then we had our numbers here specified as integers, so our d type's integers, that's why we're getting 0 and 1, and our k value is our diagonal axis. So that is k equals 0. We've put 1s across our diagonal axis. And if you wanted to change that, then it's actually a bit easier to spot on 10, so let me resize that. If we change that, then notice -1 makes it go down, and +1 makes it go up. So we can now place values across the diagonal, specifying where we want it on the diagonal. So 5 or -7, you notice it's right down here. So, and that is using the I function. So just type in np.i and then you get that. So one thing that I did miss out was the matrix function. So let's just quickly go over that. And this is another great way of creating a matrix. And you just simply type in np.matrix. And then what you do is you put everything in quotation marks and then you specify the first row remember to have gaps, not commas here, as you would normally do to separate values. Just leave it as a gap. Type in 1, or 2, or 3, or whatever you want, 4, 5, 6, 7, 8, 9, but whenever you want a new row, put in a semicolon. So when we print that, you get this value here. And so that's another very easy way. I don't think it's as quick as doing arrange and reshaping, but it is also a great way of creating a matrix. So the next thing I'm going to show you is how to combine two different matrices. So instead of the matrix command, I've just typed in mat, which also exists here, and I've created two matrices here. And then what I have done, what I want to do is I want to print A and print B, so I can show you. There we go. So these are our two matrices here: 0, 0, 1, 2, 3. And then how we join them is we use the bmat command. Bmat, and that will, and then in here we'll in the bmat brackets we'll put in square brackets and then the matrices you want to combine. Now it doesn't have to be 2 by 2. I've kept it 2 by 2 to make it as simple and easy as possible. And then what you do is you'd print it, and then they'll be joined together like that, like so. These join next to each other, so if you wanted an extra row on the bottom, you would have to modify your A and B matrix to have another set of values here, like that or something like that. So that's a really great way of joining matrices. And that is all for the matrix section. So I'm going to take a break here now, and then I'll come back to you where I will do the array calculus, and then I will also go over including date times into your Numpy module. So I'll catch you a bit later on. Hello, welcome back to this tutorial on Numpy. So previously I've shown you how to create random sample of a specified volume and range. And then I've also shown you how to choose randomly between that sample size, and then how to shuffle those results or that list of samples to create a very random and unbiased result. And I've shown you how to do that with whole numbers and with non-whole numbers. I've also shown you how to create matrices of a specified size, and I've also shown you how to reshape the matrices and how to combine them together. But I have noticed that I did miss out this bit here on bell curves and normal distribution, which I'll show you shortly. And then after I've shown you that a bit on bell curves, then I will show you how to do some basic calculus and why you may want to use Numpy instead of other modules. And then I'll show you non-dimensional arrays and then how to use the date time elements of the Numpy module. So moving on, so I'm going to be showing you how to create a random normal sample that's representative of a bell curve or normal distribution, and that comes from using the rand_n part of the Numpy module, which is accessed through typing np.random.rand_n. And what that does is it creates an array that simulates a normal distribution or a bell curve. So if you're not familiar with a bell curve, this is what a bell curve is. It's a very familiar shape. That is the shape of a bell curve, and it's all about identifying how independent variables relate to each other. And these sort of typically rely on having a large sample size. So if you have a couple of samples, or even tens of samples, or hundreds of samples, then they may not necessarily exhibit the classic bell curve. But as soon as you increase your sample to a large size, like millions or hundreds of thousands or thousands, then you should start to see a bell curve shape appearing more and more clearly. And that's what this part of the random part of the Numpy module is about. So I'm going to show you how to create an array that sort of would exhibit that sort of bell curve distribution. So how you access it is typing in rand n, and then you want to create one array. Let's start with one array, and then let's print that out, see what happens. Here we go. We have one number here. So we've just simply specified we want one set of arrays, but we haven't specified how many rows or columns we want. So it's just printed one random number. So if you want to specify the number of rows and columns we want, to type in, let's say you want one row, one column, it should still have one, like that. But notice it's got more brackets around it. That's because it's anticipating that we want an array, and at the moment we just specified one, so it looks a bit odd. But when we do something a bit more, so let's make it a bit more visible, actually, like this. Let's have 5 and 5, and then it looks a bit more understandable. And at the moment we've just created one of these samples. So let's say we wanted 5 of these samples, and we want each one of those to have 3 columns and say 4 rows, or 3 rows, let's say. And there we go. So we've got 5 sets of data here, each with 3 columns and 3 rows, and we printed them out. And these are all normal distribution arrays. So that is something very statistical that you can do with Numpy, and it's for the people who, not many people may have come across bell curves before, but if you have done, then it's something that can become incredibly useful. So moving on, I'm going to show you how to do some basic operators and why you would want to do it in Numpy. So for many programs, Numpy cuts down to whatever decimal place the number goes to, whereas modules like the math module, or even inbuilt operators, will go to as many decimal places, like maybe 10 or 100 or so on decimal places, but Numpy cuts it off, say at like 8 or 9. And so what you're left with is a situation whereby if you're using the sum or average or min or max or basic operators a lot within your code, it may be worth switching to using Numpy rather than the math module, for example, because those small tweaks will add up and make your code run a bit more efficiently and a bit quicker. And how you do that, how you access these operators, is you simply type in np.sum. So numpy.sum, and then you can print out. So we've got a list here of 1 to 5, and then if you want to print out the sum, you just type in F5, and if you print it, it should give you the sum. And there's exactly the same with the average, the min, and the max. Just type in np dot whatever you want. Make sure you include the word print. And then if you print them out, you will get the average, which is 3. Remember, that's a float. Min is 1, and the max number is 5. So I'd highly recommend using or replacing your operators with using the Numpy module, because it would make it run a bit quicker. And if you want to test that, then you can always import the time module. It is called time, and use the time.start, or and then you will be able to see for yourself how much quicker it is. It's not a lot, but if you do this, if you're using it a lot within the same code, then it would add up. So next I'm going to show you n-dimensional arrays, Now, what an array is, it's a way of specifying each point on the plane, and you have things like multi-dimensional arrays, one-dimensional arrays, zero-dimensional arrays, but essentially it's got an n dimension. So what I'll be showing you today is the ND-array function in Numpy, which stands for n-dimensional array. So I've got this short 4-line code going on here, and what I've done is specified a number 1a, and I've created a shape of an n-dimensional array of 2, 2, and then what I've done is I've put an operator within the n-dimensional array to add 1 every time. So that's why this a is important. So if I print I first time and press print, you get that. Notice we've just created a random way similarly to what we've done here, created a similar way to that. But if I then include this z function, it will look a bit different because it will go to the nearest whole number. 1. Oh, what have I done there? Interesting. And then, so you notice it's got 1 here. It typed in 1, 2, 3, 4. Notice we're adding 1 every time. Notice add 3 every time. And we can add even 100 every time if you wanted to, 120, and so on and so forth. So that is a way of creating an n-dimensional array, and then using operators within the ND-array function to transform your array to however you want. So you could replace add for floor division, to minus, divide, times, plus, all the basic operators. If you want a full list, then I'd advise you go to the documentation, and there is simply loads to choose from. But so this is a very quick way of creating an n-dimensional array and then transforming it to how you want. So finally, I'll be showing you how to create using datetime in Numpy. So Numpy does support datetime. And so let's start with a very simple example. If you type in mp.datetime64, and then you put the date with the year, the month, and the day. So year, month, and then day, with a dash. And then if we print it, so let's get a clear screen here. Like so, and then if we print that, let's get rid of this ND array here. If we print that, you'll get printed out the date. So what if we wanted to just get the year? So if we just have exactly what we had above, but we add on a comma y at the end, we'll get the year. And if we add in comma m, we'll get the year and the month, and we type in D, we get the year, month, and the day. So notice that it goes from the most general to the least general, if that makes sense. So if you type in month, it will show the month and the year. If you type in year, it will show just the year. So it works from left to right. And so the next thing I'm going to show you is how to print out a range of dates of a specified time using the Numpy module. So if we go above, if you go to the top, when I showed you how to use a random module, if I ungray it, you see here we had a range here, and that was using numbers. So if we go down to a range here, we're going to use dates instead. Notice we've got the T in the middle here. So what we have is a year. Type in mp.arange, and then in quotation marks we have year, month, date, and then we separate it with a T for time, and we specify the time as well. So we have here created a date time stamp. And what we're going to be doing is we're going to be putting it forwards every hour, and we're essentially going to be creating we're going to print out essentially a 9 till 5 day every hour. So we're going to have 2018, 10, 20, 09, 010, 11, 09, 10, 11, 12, and so on to 5. And we specified the type, how we want the information to be laid out, and we want it laid out in this format. So there are two different types of layout for date time. We've got the M8 and in square brackets NS, and we've also got date time 64 in brackets NS. So if we print this out, let's get some clean white space, press F5, you can see here we have got 9 till 5 printed out. One thing to be aware of, it's a 24-hour clock, and so we have 09 to 17, simulating printing out a 9 till 5 day. And then if we wanted to have a ranged list, so instead of printing out every hour, we're now printing out all the days between a particular month. And this time we're going to lay it out in the other way of sorting out date time, so using date time bracket NS. So in up here we had our NS as M, whereas down here our date time 64 is in days, so we're going to print out the days. If we press print here, it keeps appearing for some reason, and we can see we got every day printed out between February 2015 and March 2015. So notice there are 28 days in February, so it's printed out all 28 days. If you had 30 days a month, it would print out 30 days and 31. So that's a really useful way of using date time in Numpy module. You can then combine this with matplotlib. You can put graphs with dates on the x-axis and some independent variable on the y-axis, or some other factor on the y-axis, like maybe sales or something like that. And then it makes it a very powerful module when combined with others. So that is it for this tutorial. I've shown you, creating random samples, shuffling them, creating matrices, some basic data analysis, and using date time. So I really hope you've enjoyed that tutorial. Don't forget to subscribe to my channel and keep looking on my channel, because I'll be going through and showing you various introductions to other modules as well. So thank you very much for watching.